This is plus a square x square, a x square y square. This is minus 4 3 times. Any other? No, not any other. Now let me summarize them. This twice. First step is a square x cube, a square y cube with negative sign. So this, let me take a square, and the other one a square x cube. Okay, so this is cancelled out. A square x cube, a square x cube. These two are cancelled out. This is positive, this is negative. A x square y square. Okay, this is a square y cube, a square y cube plus, and this minus. These two are cancelled out. Okay, now a cube xy is a into x square y square twice a x square y square. This one. Now these two steps. So it will be minus a square x square left over. Okay, this is also minus twice a x square x square. Now let me take these three steps. So this is minus 3 because what I'm doing is okay. So these two steps, x by 4 and there was 1 by this one, x4 by. So out of these two, let me take xy common. If I take xy common from this, so first is y cube plus this is x cube. These two steps are taken. Okay, this cancel out. So it's minus 2a x square to a x square y square and a x square y square minus 2a x square y square. So these are minus 4a, and this is 1a minus 3 a x square y square left over. This, sorry, this one, this, and these three steps. Now only one is left over. This one. This is plus a cube xy. This is plus a cube xy. This is step was left over only. Okay, and let's start cancel out. Now let me solve it further. So this is in the denominator we have ax minus y square whole cube. So let me solve it here. So the final answer will be, this is twice. Now this y cube plus x cube equal to 3x. So this is x by out of the bracket. Now value of from first one is first equation, x cube y cube, x cube plus y cube equal to 3a into xy. This is into 3a xy. Oh, that's okay. So this cancelled out, and minus 3a x square y square. This left over term plus a cube xy divided by whatever ax minus y square whole cube. So what is this? This is the 3a x square y square and plus 3a x square y square. These two are cancelled out. So left over term is 2a cube xy, 2a cube xy divided by ax minus y square whole cube, which is this much, 2a f a cube xy upon this. So okay, this is solved. So this is the answer, right hand side. One has to just have the patience and solve the question. It will be obtained. Okay, if there is a minor mistake, negative or plus, I mean minus or plus, that can change the answer. So if we are committing errors again and again, then students are advised to do it. Okay, further, whenever any mistake committed, don't hesitate and do it again. Okay, it can be obtained. Now question is 12th, last one. Now let me take the 12th question, the last one. So it says if x equal to, okay, theta minus sine theta. Okay, this is in parametric equation, parametric term, and y is equal to 1 minus cos theta. Then solve it, then find d square by upon dx square. Then find, now this we have to find this y square at the point pi and 2. Yes. the value of x, y and y is 2. Okay, so let me solve the question here. We are dx, now differentiating a given equation, these equations, differentiating these with respect to x. Sorry, with respect to theta, I'm sorry. These with respect to theta, with respect to theta. That theta is a parameter. So first equation is x, so dx d theta equal to theta is 1. Differentiation of theta with respect to theta is 1. Alright, and differentiation of sine theta is cos theta. This is nothing but y. Okay, and differentiation of y and dy d theta is equal to 0. 1 is 0. Differentiation of minus cos theta is minus sin theta, and it will be positive. It will be plus sin theta. Okay, and sin theta, alright, this is sin theta, and this is 1 minus cos theta. Now finally let me, okay, solve it further. So dx d theta is 1 minus cos theta, which is nothing but y. So this is equal to y, because 1 minus cos theta from the given equation, these are the first equations, these two, okay, and this is y. So dx d theta equal to y, because 1 minus cos theta, which is given to us, and dy, but dy d theta is equal to sin theta. Okay, so it's not this much, not x. Let me find out what is the answer of this. Okay, so therefore dy dx, if I find out dy dx, that will be equal to dy d theta into d theta oblique dx. That means dy dx. Okay, dy dx is dy d theta. First is dy d theta, this is sin theta. We write them in terms of this, so this is me. In the denominator we have dx upon d theta is 1 minus cos theta. Let me write 1 minus cos theta. Okay, so what do we obtain here? Okay, so 1 minus cos theta is this. If I find out second derivative, you can find out second derivative of d square y oblique dx square for differentiating it with respect to x. Now here x, so this is d square y upon dx square, because we have to find out second derivative, d square y dx square. So this we have to differentiate with respect to x, but these are in terms of theta. So let me write it as d theta sin theta oblique 1 minus cos theta into d theta oblique dx. Okay, so d theta oblique, that means dx upon d theta, which is 1 minus cos theta, or y, 1 upon y, that I will substitute. Okay, this is 1 upon y, because this is y, that I'll substitute finally. Let me first find out what is d theta. This is by quotient formula. So 1 minus cos theta as it is, differentiation of sin theta numerator, that is cos theta, minus, now 1 minus cos theta we have to differentiate, but sin theta as it is, and differentiation of 1 minus cos theta is nothing but plus cos theta, plus sin theta, because minus sin theta. Cos theta, differentiation of cos theta is minus sin theta, so minus will be plus. Okay, so these two into or divided by 1 minus cos theta whole square. This is quotient rule. What is quotient rule? Denominator as it is, differentiation of numerator sin theta, differentiation of sin theta is cos theta, minus numerator as it is, denominator differentiation of denominator. Denominator is 1 minus cos theta. Differentiation of 1 minus cos theta, 1 0, and minus cos theta is minus sin theta. Okay, minus plus. That will be that one. Now let me further solve it. This is 1 minus cos theta into cos theta. Okay, minus this is sin theta. Plus sin theta into sin theta divided by 1 minus cos theta whole square. Okay, into, that was 1 upon d theta upon dx is 1 upon y. Let me write it as 1 upon y. Because dx d theta is y, and it's in the denominator. Okay, to reverse it, 1 upon y. This is 1 upon y into 1 upon y. Let me solve it here. Okay, so d square y oblique dx square is equal to, finally in terms of x and y, let me solve it. So cos theta, first multiplying by cos theta minus cos square theta, okay, minus sin square theta, sin into sin minus square theta divided by 1 minus cos theta whole square. What is this value into? This is 1 upon y also. I'm sorry. Now let me further resolve it. So what we obtain here, cos theta in the numerator minus, if I take minus and common, it will be sin square theta plus cos square theta. So nothing but 1 minus cos theta whole square into 1 upon y. So this is cos theta minus 1. Why? Because sin theta plus cos theta is 1 trigonometric. Since sin square theta, this is primary formula, everybody knows this, is equal to 1. Since this is equal to 1, so cos theta minus 1 divided by 1 minus cos theta whole square. If I take minus and common in the numerator, this is 1 minus cos theta, so into 1 upon y as well, upon 1 minus cos theta into 1 upon y. So what is this? Now 1 minus cos theta upon 1 minus cos theta whole square, so 1 minus cos theta cancel out. You will get minus 1 upon 1 minus cos theta into 1 upon y. Now 1 minus cos theta is y, so this is 1 upon y square. Alright, let me write it here. So final answer is pi and 2. So the value of this pi at pi and 2. Value of y is 2. What is the answer final? D square by dx square at pi and 2 is equal to, this is nothing but minus 1 upon, this 1 minus cos theta is y, this is y into 1 upon y, that means minus 1 upon y square, and that is minus 1 upon y square is 2 square, that means minus 1 upon 4. So final answer is minus 1 upon 4 is the value of d square by dx square at point pi by pi and 2. Okay, this is the final question. So next I'll take nth derivatives. What is the formula for nth derivative? Different type of questions are there. I mean, every topic, every question of this is very important, and next question are very important. Okay, so that I'll take tomorrow. Okay, or in the next lecture, 30th lecture. Okay, so before that, I'll advise the students that please go through the 20th lecture, because in that I have written the formulae, which are very important formulae, or whatever discussed, I have discussed in the previous lectures from the beginning to the end. Okay, to the up to 28th or up to 27th lecture. All those formulae are written in the 20th lecture. Please go through all those formulae, remember them, so that you can be master of formulae or master formulae. Whenever we differentiate a question or differentiate a function, then the formula can be remembered easily, so that we can apply that. Okay, so this is just a simple advice to the students, or piece of advice to the students. Okay, so see you then in the next lecture. Okay, bye-bye.